Physics Part 138. We've got a section summary for you. At any junction in a circuit, the total current entering the junction is equal to the current leaving it. This is, I beg your pardon, please. This is Kirchhoff's first law and is a consequence of the law of the conservation of charge. The electromotive force EMF of a supply measures the electrical energy gained per unit of a charge passing through the supply. The potential difference PD across a resistor measures the potential difference PD across the resistor measures the electrical energy converted per unit of charge passing through the resistor. In any closed loop of a circuit, the sum of the electromotive forces is equal to the sum of the potential differences. This is Kirchhoff's second law and a consequence of the law of conservation of energy. The voltage across the terminals of a supply, the terminal PD is always less than the EMF of the supply, where it is subject to a certain change as the requirement would have been there. The potential difference is always across a resistor measures the electrical energy converted per unit of the charge passing through the resistor. In any closed loop of a circuit, the sum of the electromotive forces is equal to the sum of the potential differences. This is Kirchhoff's second law and the consequence of the law of conservation of energy. The voltage across the terminals of a supply of the terminal PD is always less than the EMF of the supply when the supply is delivering a current. Because of the lost volts across the internal resistance, for a supply of EMF E which has internal resistance R, E is equal to I into R plus R, where R is the external circuit resistance and I is the current in the supply. A supply delivers maximum power to a load when the load resistance is equal to the internal resistance of the supply. Section questions. The internal resistance of a dry cell increases gradually with age. Even if the cell is not being used, however, the EMF remains approximately constant. You can check the age of a cell by connecting a low resistance ammeter across the cell and measuring the current. For a new 1.5 V cell, a certain type of the short circuit current should be about 30 ampere. Calculate the internal resistance of a new cell. A student carries out this test on an older cell and finds the short circuit current be only 5 ampere. Calculate the internal resistance of this cell. 2. A torch bulb has a power supply of two 1.5 volt cells connected in series. The potential difference across the bulb is 2.2 volt and it dissipates energy at the rate of 550 MW. Calculate the current through the bulb. Calculate the internal resistance at each cell. Calculate the heat energy dissipated in each cell in 2 minutes. Two identical light bulbs are connected first in the series and then in parallel across the same battery, assumed to have negligible internal resistance. Use Kirchhoff's law to decide which of these connections will give the greater total light output.